For our presentation, we decided to research the evolution and adaptations of the gas bladder. So gas bladders, also known as swim bladders in a lot of research, are organs that can contribute to the control of buoyancy in water for fish. They are gas-filled sacs in the abdominal cavity of mostly bony fish, often linked to their digestive system. The two gases that fluctuate through the gas bladder are nitrogen and oxygen, and by adjusting the amounts of these gases, fish are able to control their buoyancy and maintain a certain depth without having to expend this energy when they're swimming. To function these simple mechanisms, fish can either bring in a gas such as nitrogen or oxygen into the bladder to increase its volume, and this will help them rise in the water. When the volume of the gas bladder decreases, the density of the fish overall will decrease, and then the fish can go to a higher depth. In contrast, a fish can release gas from its swim bladder to gain a lower depth, and they'll do both of these things by using a duct in their gas bladder. And these mechanisms will allow the fish to adjust or maintain their buoyancy, which is essential for them moving throughout their environment when they need to escape from a predator or even forage for food. So the first of the three hypotheses that we will cover and how the gas bladder developed is the lungfish hypothesis. And this hypothesis comes from the idea that the gas bladder evolved from a primitive lung in early fish. A few things that explain this are that firstly, early bony fish had a lung and they lived in shallow waters with a low oxygen content, meaning they needed air to get the oxygen they needed. In shallow water, they could use a normal lung to go up to the surface for air. Another piece of evidence comes from research and shows that there was a budding stage between lungs and gas bladders, and it showed an intermediate stage that talked about the different anatomy of this organ. And then also, and another piece of evidence shows that fish today can retain both a lung and a gas bladder, and this is indicative of an evolutionary link. And this hypothesis is supported by not only these pieces of evidence, but also shows more research to show the evolution of gas bladders over time.
All right, and our second hypothesis is going to be the vascular theory, and this is essentially an adaptation or an evolutionary adaptation that was derived from a network of blood vessels that are found in the wall of the gas bladders in these fish. So the first piece of research that we found mentions that they believe that the vascularization found in gas bladders in many fish are connected to the circulatory system. It allows for internal respiration to occur or the gas exchange to occur, and it is found in many fish, this type of vascularization in the gas bladder. So I guess that's more or less 1 and 3 combined, but our second piece of research also states that it allows for buoyancy control through the altering of these gases in the bladder. As Lexi mentioned before, the change in density and pressure and volume of the gas bladder will allow for the fish to either increase or decrease in depth, which aids in their survival. So this is the second theory that we looked into, and then our third theory that we looked into is going to be the gut associated theory. This theory is a little bit more debatable among scholars in the field of comparative anatomy, but they suggest that the evolution of the gas bladder is derived from a section of the digestive tract. Essentially, gas bladders are located very close in proximity with the digestive tract in these fish, and it is seen in many observation of these primitive fish that they are investigating that uh, the gas bladder was absent originally in these primitive fish, and they believe that their buoyancy was controlled by a hepatic ceca, and it's essentially a muscular diverticulum within the gut. So that was the primitive evolutionary stance. And then throughout time, they believe that the gas bladder evolved and adapted into its own organ. So our second source explains that the gas bladder and gut are linked developmentally with shared genes during embryonic development, essentially suggesting that during the time of development in the fetus or in the womb, the genes that promote the development of these organs are shared in early stages, potentially displaying a link to how the gas bladder became its own organ itself. And then again, the buoyancy control in primitive fish is directed through this section in the gut. Essentially, the proximity of the gut in the gas bladder is suggested or can be linked and assumed to be associated with digestive function during those times, specifically because of the digestive connection, the fermentation of food in the hindgut, which produces gases as the byproduct, could be a correlation. And then we essentially are going to conclude with the notion that this evolutionary adaptation is found and observed in many different species and is likely to be selectively pressured through different forms of environments, different habitats, and different predators, essentially just selective pressures that are promoting the adaptation of gas bladders throughout time. It allows for fish to have a greater chance of survival in different habitats and environments through the control of buoyancy. It allows for advantages in moving freely in the water to avoid prey, forage for food, and other things along those matters.
Thank you so much for listening to our presentation on the evolution of the gas bladder.